Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at electron configuration, and we use electron configuration to describe the specific energy level and sublevel of each electron in an atom. Basically, we're talking about the location of each electron. Now, the beautiful thing about this is that we can actually use the periodic table to write an electron configuration. But first of all, let's look at the format. We have the energy level, followed by the sublevel, and the number of electrons in that specific sublevel. For the energy level, that is represented by the period number. Except for the D, it is 1 less than the period number. And then for the F, it is 2 less. Because if you look at this right here, there's a reason why this is shaded, because this actually belongs right there. So again, the F is 2 less than the S, and the D is 1 less than the period number. And the S and the P share the same period number, which is the same energy level. Now, if we look at the sublevel, there are 4 possible sublevels, S, P, D, F. For example, energy level 1 only has the S sublevel if we read across. And then energy level 2 has the S and the P. And then energy level 3, we have the S, D, and P. And then energy level 4, we have the S, the D, and the F. So keep that in mind, okay? Use your periodic table. And within a sublevel, it contains a certain number of electrons. And if we notice, the S sublevel, if we read across, it contains 1 box, 2 boxes. And each S sublevel contains 2 possible, or the maximum of 2 electrons. Where the P, we have 1, 2, 3, 4, 5, 6. So each P sublevel contains 6 electrons. But for the D, it actually contains 1, 2, all the way to 10. It's actually a possible of 10 electrons. For the F, if we count across, it actually contains possible of 14 electrons, okay? So that's how we use the periodic table. Well, each box represents 1 electron. And that's how we use the periodic table to determine the sublevel of each electron. And we know that 1 box equal to 1 electron. Just we learned before that each atomic number represents a number of protons, and each number of protons represents a number of electrons. So in a way, we can actually state that a specific sublevel belongs to a specific energy level, and in that specific sublevel contains a certain number of electrons. But that certain number of electrons right there, it is very tricky. We are talking about the sequential order of that number of electrons. For example, if we look at the S sublevel, that would be the first electron of that 2S sublevel, because it belongs to energy level 2. Then if we look at the P, it has a possible of 1st, 2nd, 3rd, 4th, 5th, 6th. Where if we look at the 3rd, it's all the way to the 10th, and if we look at the F, it's all the way to the 14th. Okay, so keep that in mind. It is the sequential order of electron in that specific sublevel. Now let's use the periodic table to determine the number of electrons in each sublevel. And we notice that in the S sublevel, if we read across, it has a maximum number of 2 electrons. What about the P? We counted, it has a maximum number of 6 electrons. Remember, we count across. What about the D? If we count across. Now, what about the D? If we count across, there are possible of 10 electrons. And the F we mentioned before, if we count across 1 box at a time, there's a total of 14 electrons. And isn't that easy? What about this right here? Determine the maximum number of electrons in each energy level. For energy level 1, it has 2 boxes possible, so that will be 2 electrons. Where the second energy level, we have 2 right here for the S and 6 over here for the P. That gave us a total of 8 electrons possible for the maximum. And then for the D, we have 3S right here. Then we also have 3D. That's 2 right there. And there's 10 going across. Then going up, we have 6 for the 3P. That gives us a total of 18 electrons possible. What about the 4th energy level? We have 2 here, then 10 across there, 6 for the P, and then we have 14 going down here for the F. What is 2 plus 10 plus 6? That will give us what? 32 electrons possible. So that's how we use the periodic table to answer some of the basic facts about each energy level as well as the sublevel. Now let's get back to electron configuration. Describe the last electron in each atom below. So we are talking about the location of the last electron. And for carbon, which is C right here, this is carbon right here, okay? Now, if we look at carbon, what sublevel is the last electron gonna be? It's gonna be in the P. So we know it's gonna be in the P sublevel. To determine the period, we go back to carbon, go across, and determine what is the period number. In this case, it is the period number 2, so that is energy level 2. And what is the sequential number in that specific sublevel? This is the first one, and that's the second one. So there you go, 2p2. This is the description of the last electron in carbon. What about sodium? Sodium is right here, okay? And we know that this is in the S sublevel, and this S sublevel belongs to period number 3, so that's energy level 3. And what is the sequential order of electron in this S sublevel? This is the first one. So there you go, we have 1. What about for copper? So copper is right here, okay? And it's in the D sublevel, okay? So that's copper, is in the D sublevel. And in what energy level is it? Right there, it is in energy level 3. Remember, it's 1 less than the S. So that is the third energy level. And what is the sequential order in terms of the electron in that sublevel? And what is the sequential order of the last electron? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So therefore, this must be the 9th. So this must be the 9th electron in the D sublevel. Let's try uranium. Oh, uranium is all the way down here. Okay, so uranium is right there. Okay, so we know that this must be the F sublevel. And what energy level is it? It's in the 5th energy level. And what is the sequential order? 1, 2, 3. So that would be the 3rd electron in the F sublevel. Now, the last example is oxygen. Oxygen is right there. What sublevel is it in? It is in the P sublevel, and this P sublevel belongs to a specific energy level of 2. So we have energy level 2, and what is the sequential order? 1, 1st, 2nd, 3rd, 4th. So that would be the 4th electron in the P sublevel of that energy level 2. So that's how we use electron configuration to describe the last electron of any atom on the periodic table. Now, are you ready to write an electron configuration for all the electrons in an atom? Let's try helium. Helium is right here. And when you write electron, you always start from energy level 1. So this is where we start, right here. So we go across until we reach our last element, which is helium, right there. Which in this case is gonna be, what do we have? 1, energy level 1, right? Or we have the S sublevel belong to energy level 1. In this case, 1, 2 electron. And that's helium. And we're done. What about boron? So boron is all the way down here. This tells us where we will stop. Just like we have helium, we stop right there. But if we have boron, so for boron, we have it right here. This is where we are going to stop. But where do we always start? From the very beginning. We always have electron at the very lowest energy level. So we're going from here, going all the way across, but we don't have anything left. So we have to go to the next energy level. Just remember we're talking about electron going shell, right? If this shell is filled, we had to go to the next shell. That's what energy level is about. It's about the shells, okay? So in this case, we have second shell, go across, and we stop right there at boron. So we have at the very beginning, we have energy level 1, and within energy level 1, we have the sublevel S, and this sublevel S has 1, 2 electron. Do we have any P sublevel in energy level 1? No. Then we go to energy level 2, and in energy level 2, we have the S sublevel, okay? And within the S sublevel, we have 1, 2 electron. But we also have the P sublevel. Because now there are 2 different sublevels, we have to write them separately. So we have the P sublevel, and this P sublevel right here belongs to energy level 2 again. And what is the electron in this P sublevel? Boron is right here, so this is where we are going to stop, and that is the first sequential number of electron for boron. So that's 1. And that's pretty much it. Okay? Now let's try something really hard. All the way down here. Okay? So for boron, we stop right here, but for chlorine, we actually stop all the way down here. So to write an electron for chlorine, we have to start all the way from the very beginning, go across, then we go to the next shell, that's energy level 2, go all the way, and we finish completing the second shell. Then we go to the next shell, which is the third energy level. And notice how I read across, and I kind of ignore the D sublevel. That's the beauty behind writing electron configuration. You just read across. You don't worry about ending, just read across, okay? So in this case, we stop right there at chlorine. So for chlorine, we start at 1s again. For the first energy level, we start from the very lowest energy level, we have 1. And the first energy level has 1. In this case, it has 1s. And the s has 2 electrons. Okay, and then what we have here is we go to the next shell. We have energy level 2, which containing the s sublevel again, and that s sublevel has 2 electron. Then we go to the p sublevel, which that p level also belong to the second energy level. Again, although they belong to the same sublevel, because there are 2 different sublevels. Although those 2 sublevels belong to the same energy level, because they are 2 different sublevels, we had to write them separately. So in this case, this p sublevel, specifically 2p sublevel, contains 6 electrons. 1, 2, 3, 4, 5, 6. And then we have to continue, and the second energy level are done, so we need to move on to the third shell, which in this case, the third energy level, we read across. Remember, we read across. So we have 3s2, and that s has how many electrons? 1, 2. We have 2 electrons. Then notice how we skip the 3d because the d is all the way down here, okay? So we just read across. So in this case, the 3 has 3p, which in this case, 1, 2, 3, 4, 5. Hey, look, we have chlorine right there. So we got to stop right there. So that is the 5th electron in p sublevel that belong to the energy level 3. And that's pretty much it, okay? What about we have Mn? Let's talk about the one with the D sublevel. So this is manganese right here. It is right here. So that's where we're going to stop. The element tells us where to stop. This is the last electron, okay, of that specific element. So we are going to start from the very beginning. That's the first shell. But that's not enough. So we need to go to the second shell. Then we need to go to the third shell, which is period 3. Then we need to go to the fourth shell. And then lastly, we have manganese. So again, we go from the very beginning. We have 1s2, 1, 2. Then we have 2p. And this 2p has, well, not 2p, we have 2s2, followed by 2p6 because of the same energy level. And then we have the third shell, which represents 3s2. Remember, reading across. Then we have 3p6. Okay? And then we go to the next shell, or the next energy level. Here we have 4, and this is s, so it has 1, 2. We're not done yet. Manganese right here. Now we read across. Then we have, ooh, it's not 4 for the D sublevel. It's actually 3. So we have 3D, 1. This is the first, second, third, fourth, and fifth. So that is the 5th electron in the D sublevel that belongs to the third energy level. Now you know what I mean by reading across the periodic table. Okay? Want to try another one for bromine? And notice how bromine is right here, right? So what do you think is going to happen? We are going to continue until we get to bromine. That's where we're going to stop. And you should notice the pattern right now. And basically everything is the same until you get to the very end of your element. So all I have to do for bromine is I just copy whatever I have from the very beginning, which including manganese, okay? So I have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 3d10 is right here, 3d10, but bromine is right here. So we are going to continue, which we have now, 4p what? 1, 2, 3, 4, 5. There you go. I don't even need to look at the periodic table if I know what manganese is. Let's try the very last one. Let's try strontium. Strontium is right here. So we actually have to pass bromine and go all the way to the next energy level. And then we have right there. So again, I can just copy whatever I have for bromine because we know it's gonna be the same. 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p. Notice how we pass bromine and we completely fill in that p sublevel, and we go to the next level. Here we have 5s, and that's the first electron, that's the second electron. And there you go, that would be for strontium. And that is how we use electron configuration to describe the location of every single electron in an atom.